Alright, this is a lesson on 4.1 for Precalculus, angles and their measures. You're going to find a lot of familiar information in here from last year. By the time you're done with this section, you should be able to convert between radians and degrees, find arc lengths, and then some new things for you would be convert to nautical miles and solve problems involving angular speed. So what we're going to start with is we're going to start with something that you remember and know, and that's how to convert between radians and degrees. So in order to do that, let's just remind you here what a radian is. A radian, if you have a central angle of a circle that measures 1 radian, then it intercepts an arc with the same length as its radius. It's one way to think of it. I'm going to actually show you the conversions from degrees to radians here and radians to degrees right away because you used that before, and then we'll talk a little more about what radians are a little later on. So your degree to radian conversion and radian to degree, if you're going to convert radians to degrees, you're going to multiply by 180 degrees over pi radians. And if you're going to go from degrees to radians, you're going to multiply by pi radians over 180 degrees. What's an easy way to remember that? Well, just think about if you have radians, most of the time, not always, but most of the time, if you have radians, you have a certain number times pi. Again, not every time, but generally that's how you think of radians. Well, if you have a certain number times pi, you're going to multiply by 180 over pi to get rid of the pi's to get to degrees. So once you get to degrees, generally you don't have any pi symbols or the number pi in your answer, and vice versa for going from degrees to radians. When you're talking degrees, generally you don't have the number pi in your answer, so you would multiply by pi over 180, and that would give you pi in your answer. Just one way to remember that. So here's an example of working with degrees and radian measures. If I want to know how many radians are in 135 degrees, well, remember, if I'm going from degrees to radians, I'm going to multiply by pi over 180. So I'd have 135 pi over 180, and of course, you would simplify that. 135 over 180 would simplify down to 3 over 4, so you'd have 3 pi over 4 radians. If I wanted to go the other way, how many degrees are in 7 pi over 6 radians? Well, then I'm multiplying by 180 over pi. And again, you would simplify your fraction. Notice, which is the usual case, the pi's would cancel out, and you just have simple arithmetic to find your final answer. Now, normally, you think of degrees using your little degree symbol. Like if I'm talking 60 degrees, you use this little symbol here to represent degrees. Another thing we're going to talk about is talking about angles using DMS, or degree, minutes, and seconds. What we do is we're working with basically every degree that you have, every 1 degree that you have can be split into 60 minutes. And those 60 minutes, so imagine taking this 1 degree, this very small degree, 1 degree, and splitting it up into 60 parts. Well, those 60 minutes, they're represented using this symbol here. That means 60 minutes. And then each one of those minutes, they can be split up into 60 seconds. And those two tick marks represent seconds. So when you see the DMS, degrees, minutes, seconds system for angular measure, each degree is subdivided into 60 minutes, and each minute is subdivided into 60 seconds. So what we're going to do right now is we'll go through an example where we use that and we convert that system. So if I want to convert 37.425 degrees to DMS, or degrees, minutes, seconds, well, I've already got my degrees. Degrees is 37. Now I need to figure out how 0.425 of a degree converts to minutes and seconds. Well, to do that, I would take the 0.425 and multiply it by 1 over 60. That's going to convert it, or tell me how many minutes I have. Oh, excuse me. I went the wrong way here. I'm going to take that 0.425 and I'm going to, it's 0.425 degrees, I'm going to divide it by 1 degree. Well, how many minutes are in 1 degree? 60. So essentially that's the same as saying 0.425 times 60. Well, that's going to be 25.5 minutes. Okay, so now what I have here, since I have a decimal here, now I can take that decimal and turn it into seconds. Well, so right now, I've got 37 degrees, 25 minutes, and I still need to get my seconds here. So I'm going to, again, take my 0.5 and multiply it by 60 seconds, and since that 0.5 is minutes, divided by 1 minute, so what we'll be left with is 30 seconds. So what does all that mean? Well, that means 37.425 degrees is the same as saying 37 degrees, 25 minutes, 30 seconds. We can go the other direction too. If you're given DMS, degrees, minutes, seconds, you can convert that to degrees in the traditional sense that you all know. Well, to do that, it's actually quite easy. You're going to take your 42 degrees, and you're going to add to it your 24 minutes divided by 60. And then you're going to add to that your 36 seconds divided by 60 times 60, or 60 squared, which is 3,600. You're going to do that all the time, so I'll just write that in right now. Once you simplify that down, you're going to have 42.41 degrees. And it works that way every time. Now, when you're dealing with navigation, the course or bearing of an object is sometimes given as the angle of the line of travel, measured clockwise from due north. So don't make this mistake. When you're talking navigation, you're always measuring clockwise from due north every time. So whatever direction you're traveling, say you're traveling this way from here, in navigation, you're going to be traveling so many degrees from due north. In this case, it would be, well, let's say it'd be 120 degrees from due north. Or we might say it has a bearing of 120 degrees. And you would have to just know, well, that's 120 degrees from due north. Along with this, you would have to know basic compass readings. So you should realize north, south, east, and west. You all know that. And then you should realize northeast would split this in half, or northeast would be describing a 45-degree bearing. This would be southeast, southwest, northwest, and then you should be able to split those one more time. If you split them again, here we would call this north, northeast. You should realize quite quickly that that would be a bearing of 22.5 degrees. And similarly, you should be able to find the rest of these quarter marks, if you will, per quadrant. If you went halfway in between east and northeast, well, you would call that east, northeast, because you're heading east and you're going north of it. Down here, we'd be talking east, southeast, and so on. The next thing I want to remind you about, which you've done before again, is how to find arc length. So if the central angle that you're given with radius r is measured in radians, so if the theta, the central angle, is measured in radians, well, then to find the arc length s, you simply take the number of you take the length of the radius times that measure of the central angle, and you're done. So if your central angle is given in radians, you just take that times the radius. That gives you the arc length. Remember, arc length, so that's our circle. Remember that arc length is simply the measure or the length of an arc described by some central angle and some radius. So if you're given this angle in radians and you know the radius, that arc length is simply the product. If you're given the arc length in degrees, well, then you're going to have to take, and you're basically converting the degrees to radians and multiplying by the radius. So you're going to take the degrees that you have times pi over 180 and then multiply by the radius to get the arc length. So this formula here is if you're given the central angle in degrees, whereas the one up top here is when you're given the central angle in radians. So using what we just talked about, find the length of an arc intercepted by a central angle of 1/4 radian in a circle of radius 3. Well, you're given the central angle in radians and the radius of 3, so that means your arc length is going to be theta times r, which in this case would be 1/4. That's a 4, in case you're wondering, times 3, which would be 3/4. So real quickly here, the perimeter of a 30-degree slice of a large 8-inch radius pizza, we're trying to find the perimeter of that. So the distance around the outside of this pizza slice, which has a 30-degree central angle, you do that basic work again. So you're going to take, since now this time it's in degrees, you're going to take your degrees, convert it to radians, so times pi over 180, and multiply by the radius. 4.2 inches is what you would get. Now that just tells us the arc length. Of course, you then would have to, since you're looking for the perimeter of the slice of pizza, you'd have to add 8 inches twice for the two sides. Obviously, those two sides would be equal to the radius, and the arc length you found would be that crust on the outside. There are just a couple other things we need to mention here. When talking about angular and linear motion, you need to understand the difference. For angular speed, we're talking about things like revolutions per minute. So we might be talking about like how many times your tire might rotate or things like that. And then when we're talking linear speed, it's going to be like miles per hour. And a lot of times we'll need to combine the two or compare the two to get the answers we're looking for. I'll go over an example of that shortly. I just wanted to mention a nautical mile, something you probably haven't used before. It's the length of 1 minute of arc along the Earth's equator. So some simple conversions for you for that is 1 statute mile is approximately 0.87 nautical miles. A statute mile is the miles that you're used to using. Or 1 nautical mile is 1.15 statute miles. We'll go over a couple examples here now. So here's an example of using angular and linear motion. Consider, let's say, Big Mac has 36-inch diameter wheels, and they are rotating at 360 revolutions per minute. We need to find the speed of Big Mac's truck in miles per hour. Well, to do this, we're going to use a series of conversion factors to get to miles per hour from 360 revolutions per minute. Here's how it'll work. So we'll take the 360 revolutions per minute, and we got to convert those to hours. So we know that there's 60 minutes in an hour, so that'll get rid of the minutes. What we'll do next is the 360 revolutions. Well, 1 revolution is going to be 2 pi radians. And the radians, well, we know that since it's a 360-inch diameter, the radius is going to be 18 inches. So for every radian, we'll have 18 inches covered. From there, we're going to look at, we don't want inches, we want actually miles. So we know that there's 12 inches in a foot, and we know that there's 5,280 feet in a mile. So what does that leave us with? Well, it leaves us with miles per hour. And when you multiply the top, everything on top and everything on bottom, and divide, you end up with approximately 67.47 miles per hour. This should be enough information to get you started. Soon to come, there will be another video going through some example problems from your homework.